Hey, good morning, everyone, and good evening. Just give me a couple more minutes. I'll wait for there are any joiners. Okay, so we'll get started. I have informed the few expected candidates also to join. So let me see. So I'll share my screen. Okay, so I hope you can see my screens now. Before getting started, I just wanted to make sure that is everyone able to hear me clearly? And you don't need to record this, Jyoti. Anyway, this session is getting recorded. So you will get the video recording of this session, every session. Okay?
Thanks, Shiva. That works. Thank you.
Yeah. Okay. Just wanted to check with you before I get started. Is everyone fine with audio and screen sharing setup things?
Yes, sure.
Okay. So is everyone clear with my voice?
Yeah.
Okay. And everyone able to see the screen sharing? There are no blurs. So you can see the screens clearly, right?
Yes.
Okay. So first, feel free to raise your questions in the chat box. I'll try to go through your chat box questions first. And if it is stopping, uh, you can stop me immediate as well if you have any urgent questions. Okay. So before again jumping on to the technical things, so I know most of you are from my previous batch candidates only, but I want you to introduce yourself to the rest of the members among the group. So I'll get started with in alphabetical order. Akhil, just introduce yourself to the group. Where are you from, and what is your current experience, and what is your relevant experience on big data, like, and any other tools that you are working on, any programming language experience. So just to give the confidence for others also that how much level of experience do you have, and yeah, so what are your expectations?
Yeah, hi everyone. This is Akhil. Good morning, all. Currently, I'm working in Ford, Michigan, as a data scientist. There, in previous, I worked as a Hadoop developer in HCL America in Melbourne. So I have an working experience with Hadoop like almost 1 year. I'm in. Yeah, now I want to learn Spark, and I do have a good knowledge on Hive. Now, yeah, so that's it.
Okay, yeah, thanks, Akhil. Devi?
Hi everyone. I don't have any real-time experience on Hadoop Big Data. I had a training with Shiva previously. I was trying to get, I was kind of doing some interviews and all that stuff. But recently, most of them are asking for Spark, and I was more interested in that also. And my background is from the data warehousing ETL Informatica as a developer. Currently, I was not working, and I was more. I have good knowledge from the previous training on the Hive and HBase and all this stuff. So I think I can learn easily on the Spark and all that stuff.
Yeah, definitely, Devi.
Yeah.
It's
Yeah.
not at all a big deal. So, in my opinion, Hadoop is bit complex than Spark, because you already have set up stepping stones for Spark. You know the distributed cluster processing, how does
Right.
it work? So it's similar. It's the same like your YARN or your HDFS architecture kind of stuff.
Sure.
So
The main concern is I was.
programming also becomes a little easier here with the easy language Scala. It's something looks like Python. So I don't think so there's any issues.
Yeah, the main concern is I was located in the Seattle, Washington area, and I was looking only in the preferred location. And most of them people are asking on the Scala, Spark, advanced of the big data tools, like advanced tools. That's what they're asking. So I was more concerned about that.
Okay. Scala, those things, right?
Right.
Scala will be anyway covered in our training, don't worry. So you will not get anything beyond that. Okay.
Okay.
That's
sure. Thanks, Shiva. Yeah, that's it.
Okay. Thanks, Devi. Dinesh.
Morning, Subbu.
Hey, hi, Subbu.
Hi,
Dinesh.
hi, Shiva. Thank you.
I'll just come back to you, Subbu. Just give me one. Dinesh, for some reason, I'm not able to hear you. So are you able to hear me? Dinesh, at least you can chat. So my voice is not getting audible. Okay. So you are able to hear me, right? Yeah, then at least, okay. So that part is okay. Okay, no problem. Jyoti. Hi, Jyoti. I think you are on mute.
Hi, everyone. This is Jyoti. I live in Central Zone, Houston, US. I have over 18 years of experience in IT. I am a technical architect level now at oil and gas. My experience, I have only Google experience with Hadoop. Since the time I Googled, the first website that popped up was Shiva's, and I was very impressed with this website. So I just called him up, and then I enrolled in this training. My expectation out of this training is to be able to give the certification exam and get comfortable with all the buzzwords going in the industry. I'm hoping Shiva would be able to help me with all that. So good to see you all, and we'll be in touch.
Yeah, thanks, Jyoti. Yeah,
Thank you.
Okay, don't worry. Hey, hello, Mani. Manichandra? I think even not able to hear you as well. Mani, can you hear me?
Hello.
Hello? Yeah, Mani. I can hear you now.
Okay. Hey guys, this is Mani. I'm from Columbus, Ohio. I don't have any real-time experience with Hadoop except like a couple of months. My company has recently started implementing Hadoop as a data warehousing thing. So I know Shiva from like a couple of months. So yeah.
Okay. Sorry for delaying.
No worries.
Okay. Yeah. Okay.
Thanks.
Okay, thanks, Mani. Yeah. Raj.
Hello everyone, my name is Raj Kamal. Am I audible?
Yeah, very. Your voice is very low, but I can manage. Raj.
Okay. So I have 1 year of Hadoop real-time project experience. I'm currently working as a Hadoop developer and located in Pune, India. And as there are some client requirement to work on real-time streaming data, Kafka and Cassandra. So I have started learning these things and I am from Java background. That's all. Thank you.
Okay. Thanks, Raj. Hi, Satish.
Hi, hi, Siva. Hi, all. Previously, I worked as a DBA. Right now, I'm not working anywhere. I want to shift my platform. I want to go as a developer. So I took Siva's previous Hadoop class. Now I'm taking a Spark class. I loved his teaching, so I just want to learn the technologies, whatever he teach.
Yeah. Thanks, Satish. Okay. So last one, Subbu. Just introduce yourself to the team. That's it. Hey, Vijaya. Subbu?
Sorry, it was in mute. Are you able to hear me now?
Yes, I can hear you now.
Okay. Hi, Siva. Thank you so much for the opportunity given to us to attend your training. Hi, everyone. My name is Subbu. I'm from New Jersey. I've been in the industry for the last 18 years. I've been working in test automation also for the last 12 years. For the last 2 years, I've moved into big data. Also, I'm doing MS Analytics from Harrisburg University. I'm studying all big data architecture, analytics subjects too, and risk modeling, everything. And also currently, I'm working in a financial company on the big data projects. And also, I'm working in a Spark scale too. But why I joined this training program is I just want to upgrade my skill set, and I want to become hands-on so that I can handle the requirements of our clients on a day-to-day basis. That's the reason for joining the course. I'm running a company called Piefora, Piefora, Piefora.com. I started this recently, and I'm sponsoring my the candidates also here with the Siva. Siva has accepted to conduct training for our company for the candidates I'm positioning. Thank you, Siva, for that.
Yeah, thanks.
This is about my introduction. Gradually, I can share with you more one by one. Thank you.
Okay, no problem. Yeah, and one more thing, like from my side as well, to make it clear. So I think, I'm left with one more person in the group. Let me complete that. So then I'll explain you what is the process, how the training goes, and what happens after the training, and what kind of things that you can expect from me. Hi, Vijaya.
Hi, Shiva. Hi, everybody. What is this, Shiva? You want...
Just kind of introduction, Vijaya. Just introduce yourself to the group, that's it.
Oh, okay. Hi, this is Vijaya. I'm from Canada, Toronto. And I've been working in enterprise data warehouse. I'm in the Informatica Technologies, and I'm working as a production support analyst. And so I'm just looking forward to work in this Hadoop and big data stuff. Thank you.
Okay, thanks, Vijay. So I see Ranjit also joined. Okay, so let it be. I think he is not in audio. Okay, so first thing that you can expect from this course in complete, like just let me.
Shiva, sorry, Vijaya. So this is just starting, right? I did not miss anything, right?
No, you did not miss anything. This is the day one, just the introduction day. That's it.
Oh.
Okay.
Okay. Okay. Thank you.
No one has missed anything. Even though I shared the demo video with all of you, and I'll anyway going through the basic overview of covering the demo part as well. Okay. You haven't missed anything. No one has missed anything. Okay.
What happened?
Okay. So so few things that I would like to make it clear. So before we get started, so Spark, as many of you might be knowing, so it needs a prerequisite of Hadoop understanding. Of course, you can learn Spark without the Hadoop also, but coming to the reality, so in real-time projects that you expect, no, there was no separate demo session happened this year. Okay, so I just shared the demo videos. Demo video means sample videos from the previous batches. Okay, that's it. Okay. So also please try to post your questions to everyone instead of directly to me, so that when I'm answering to your question, others will understand the context. Otherwise, they feel like I'm jumping between the context. Okay. So the basic prerequisite is understanding of basic Hadoop. You don't need much experience on this, at least the architecture. So HDFS, what is name node, what is data node, that much, and a few HDFS commands. So few HDFS commands and a little bit of yarn architecture. So even if you had any problem learning this yarn architecture from somewhere else, so most of our previous batch candidates, they can very well, they can very well pick up. I don't see they'll have any issues. But for others, like there are only few people from outside. And one good thing is that except Raj Kamal, everyone are from North American only. So even if you have any time constraints, we can do a little bit of adjustments with the batch timing. So we can come back to that later. But coming to the prerequisites of the course, so you need basic understanding of HDFS, yarn architecture, and understanding of MapReduce concepts is an added advantage. Even if you didn't have, that's fine. Spark concepts will also look a bit similar. Spark concepts will look similar to MapReduce concepts, and Scala programming language that we'll be undergoing in this training. Scala programming language concepts will be bit similar to Python and Java OOPS concepts. Python functional programming concepts and Java OOPS concepts. Okay, so even if you are brand new to Scala programming without having Python and Java, that is fine. No problem in at all. Only thing is, if you know Java and Python, you'll start comparing with those languages, and there is a scope for confusing also. If you are brand new to Scala directly, so just take it as that is a new concept for you. That's it. Okay. And in my previous batches, I have taught Scala programming language, but comparing with Java and Python. But people started getting confused with there will be some differences. And especially for the candidates who are not coming from Java background or Python background, so they are struggling to understand the Java concepts first, and then understanding the differences between Java and Scala, and then finally just sticking to Scala is becoming difficult for them. So instead of that, so later I stopped comparing with Java, Scala. So why I am giving this heads up is that there are a couple of Java programmers also, and you will expect from me that to give you the differences, give you the similarities and differences for each topic. So which I'll not be doing, just to make everyone else clear, okay? Unless until that is a buggy question for you, so I'll make it clear, okay? Only if it is needed very much, then I'll explain. Otherwise, I'll be just making the Scala concepts as just a fresh concepts for you. Are we going to practice the exercises in Java or Python? No. So we'll be practicing in Scala only. That is one another thing, and most of you might be knowing Spark is a multi-language support. So you can do the programming in Java or Python or Scala, but Spark framework itself has been written in Scala, and the Scala, no Ranjit, we cover so everything through Scala oriented only, but I can help you. It's nothing but it's the same API. Only thing, you just need to use the right method from the PySpark, Python. That's it. Okay. So the reason which we cannot cover all these languages because people come from different backgrounds. That is the reason why I included Scala programming language also the part of the training course, so that at least everyone is common or good with one programming language. So otherwise, some people will be coming from Python background, some people will be coming from Java background, and some with none. So it would be a bit difficult for me to bring everyone onto the same page. That is the reason why we teach first Scala, so that people from different backgrounds will first get comfort with Scala, and then you can start programming your Spark with Scala. And Spark and Scala has more tight integration or better integration with any other languages. So if you expect any new feature in Spark, first you can expect those features available in Scala programming language than the other two as well, than Python and Java. There are some Spark streaming concepts that are still just available only in Scala, but not in Python or Java. Okay, but slowly, I mean, they will also be supported. But so one thing that I'm just giving from the reality, from real-time experience, that you see any new features appearing in Scala than in other two languages. Okay. And so one more thing, this is a Spark developer course. Also, you can consider this for architecture related decisions. So these all also we can discuss. And obviously, this is not an administered course. Okay. You will get basic idea. I'll guide you. So how these will be configured, maybe in case if you are interested. So what are the configuration parameters, these things. But this is not a pure Spark administrator course. Okay. So this is both kind of developer or advanced developer, whatever you call, or architecture course. So it's part of this one only, Subbu. Okay. And one more thing, Spark has many rich features, but here in our course, what we will be covering is data engineering. Okay. So mainly data engineering part will be covered, but not the data scientist, not the data science, which means, so you will get, of course, I have made it clear in my Spark course contents, but again, like, so people might be having different expectations. Spark native, which are like kind of core concepts, and Spark SQL, so which is getting more popular these days, and Spark streaming. So these things you will get out of the course, and the prerequisite for this is one programming language, Scala, obviously you'll get, and one additional streaming framework, Kafka, will be shown in the training program. Okay, so what will not be covered in this course are Spark MLlib. This is purely for data scientists, machine learning. This is something like Math in real time in Hadoop framework. So this will not be covered in our course. And Spark graphics. This is something which is not fully matured as of now. So this is kind of again related to the science part itself only. Will you cover various performance tuning use? So those real-time things, those you just expect under the native stuff itself. Those are default ones. Okay. So I'm just talking inside these topics. I'm not talking about which concept will be covered and which will not be covered. So I'm just talking about on overall. These are kind of different modules under Spark. Which of the not covered topic is needed for certification? For certification, you might need a little bit of Spark MLlib. That is only if you are going through Databricks. So if you want to get certified through Databricks, so you need MLlib. Otherwise, if you want to get it done through Spark Cloudera, so I don't think so. You need a Spark MLlib also, or just Spark native SQL and streaming are sufficient. Okay, so that is the engineering part. Why I'm just separating out is people sometimes expect that this is also Spark, but under Spark, no one will do both of these things together. That's for sure. Yeah, you can. So you expect 90% of the things from the data engineering part only, Subbu. But Hardenwork Spark certification I haven't done, so that's why I'm not 100% confident that you'll not get anything from Spark MLlib. But 90% of the things you will get from engineering part only. Okay. Only thing, if you are getting certification through Databricks, then there is chance that at least 15 to 20% you may expect from MLlib also. Some algorithms from MLlib also. Okay. This is a bit tricky question. So which one will get more recognition? So anyone will have more or less equally the same recognition, in my opinion. This is just, so all you need is, all just that helps is for picking up your resume in the interviews, that's it. Beyond that, it will not help much anywhere else. Even though your resume is got picked up for your interviews, you just have to crack your interview anyway with all your real-time experience or whatever you get from the course. And yeah, so you have to survive once the job is, once you get the job, anyway through your practice only. Okay. Yeah, sure. No, don't worry about that. Okay. Okay. So then, yeah. So let's get deep dive into the topics. Yeah, first, today's session, you don't expect much. Okay, it's kind of just setting up the frequency between all of us. And so, what any general questions for you, and what will be covered? What are the pattern for course, and what is the contents, and how we go? Any setup things that you need, so you'll get all those things from today's session. Okay. Okay, so I hope everyone is fine with my voice clarity and yeah, the pace of my audio as well. Okay. Okay. So next. So I hope most of you know about myself before I get started. Um, yeah, and if not, maybe one or two guys. So myself, I have almost 9 years of IT experience, out of which almost close to 5 years into big data, which almost 2.5 years or 3 years into Spark. I have been taking the Spark sessions from last 1.5 year and Hadoop sessions from last 3 years, Hadoop batches. These days, getting less requests for Hadoop, but more on Spark. So I'm hosting one open source blog, so Hadoop tutorial.info. So most of you, I mean, not most of you, every one of you got a reference from this blog only and reached me. And unfortunately, these days I'm not much contributing towards this blog. So whatever the contents are there almost 3 years back contents. Of course, I covered all the latest versions at that time, which means Hadoop till 2.5 or so. Yes, I'm a full-time architect, Subbu. So yeah, I'm coming to that as well. So I'm a full-time daytime employee. I'm a architect role, and I was senior lead developer role till mid of last year, and after that purely into the architect role. And apart from that, I do these consultancy services as well. So I have a support team as well for me. Of course, they are also full-time employees, but we do like additional consulting services, any kind of job support. When it comes to individuals, once after the completion of the course, we do give the job support. Like there are a few folks who are currently taking the job support from our previous batches. Like they get through the trainings and they get through the interviews, and once in a while, okay, it's not that continuously they might be taking. So once in a while they got some tricky requirement, so which they were not able to complete, or initial, so 1-2 months, even after the training is completed, even after practice, there will be minor differences, or there will be lack of confidence. So during that stages, we'll provide that hand-holding support. Yeah, this one. And yes, coming to the consultancy services, handling the POCs and projects from our side also. We do provide, if there are for some kind of some startups, we did deliver almost like 4 to 5 projects, low level, I mean, not full length projects, kind of 3 months, 2 months efforts, POCs or projects to a couple of Canadian Toronto based companies and one in Dallas. Yeah. So if there are any senior folks who are expecting anything, any POCs or anything to be done for your clients or something. So if you don't have bandwidth, we do provide that consultancy services as well. Okay. Okay. Yeah. Thank you. Just give me a second. Okay. So let me this is just a kind of basic introduction. This one is completed from my side. So I don't think anyone in a situation to get these things. So I hope everyone knows what is big data, what are the different terms that we use for data sizes, like GB, terabyte, petabytes, these things. Even though we give all these terminologies, no one except big fancy companies like Facebook or Yahoo something, no one is in a stage that they are maintaining petabytes of information. You will see all your clients will be around in terabytes only. So most of the times you will talk in terms of GBs, gigabytes, or terabytes. Okay. So only if you are working in very, very big multinational company, so you may expect either 1 or 2 or maximum of single digit petabyte. Okay. So before, these are just kind of so evolution steps, not much important, even if you don't pay attention. But anyway, just try to see how does this evolution happen. So anything which is huge in size, if you want to process, the fundamental approach that anyone has chosen is distributed processing. Okay. So distributed processing. So in distributed processing itself, we have different tools or different enterprise softwares or technologies has evolved during the different generations. Like, so out of these, the first generation distributed systems are like this EDWs, enterprise data warehousing tools like some Teradata, Netezza. These tools has evolved. So these are completely proprietary tools, which means commercial, fully licensed, enterprise licensed. They are not open source. And even though you have to pay a lot of money on them, they have a lot of limitations of scalability. So these are all history you might be knowing. So that's the reason why every client is migrating to the open source, and so more scalable tools. So out of that, two features, open source and scalability. So the first one that solved these issues through this means is Hadoop and some kind of NoSQL databases. NoSQL databases like Cassandra or HBase and other NoSQL databases. So these will also work. They are, from cost wise, they are cheap. Even if you go for enterprise license for this Hadoop from Cloudera, Hortonworks or Map or anyone, very, very, very cheap when compared to these proprietary tools like Oracle, Teradata, Netezza, these things. But from processing speed wise, they have their own limitations. These are all kind of batch oriented and not suitable for either near real time or real time. So batch oriented means, so if you can wait for few hours, let's say you have received some input data and you can process that data and you can give your results in 5 hours or 6 hours, that is something kind of batch oriented. So if you can expect your results within 5 minutes, 10 minutes, around that turnaround time, so that is something like near real time. And if you expect your results to be within few milliseconds or seconds, so that is something kind of real-time processing. Okay, so even though Hadoop and NoSQL, this open source framework has evolved in this space, so they were limited to batch processing. They were not able to satisfy all the requirements of real-time or near real-time needs in the industry. So that's where the third generation, so distributed systems that came up, out of which, so currently the most popular one is Spark. And there are few tools that are getting these days, at least getting tried out, being which means like people are trying POCs on them, like Apache Flink is one another thing that these days people are trying to perform some POCs on them, but not yet started anything. But in this third generation distributed systems, right now the most popular and used one in the production is Spark. Okay, so using Spark, you can do both batch and as well as real time. But one limitation from Spark is, you could say both limitation and as well as advantage at the same time, the same thing, which is heavy usage of RAM memory or main memory of your resources. Okay, and Spark has integration flexibilities with many frameworks. All those things we'll discuss going forward. So yeah, Flink we can talk about sometime. The data flow or Beam, which even I did not do anything much on that. Okay. So how much RAM is something that this is kind of not the context to answer this question, Raj. This depends on the, yeah, you need more concepts to understand how much RAM. Okay, so we'll see that slowly. Okay. Yeah, sometimes, so let me get some context to that. I'll see to give basic idea on Flink, Apache Flink, but data flow or Beam, which I'm not having idea on them, but see if I can give anything on that. Okay. So it has integration with your HDFS and your local file system as well. And your yarn distribution framework. So these on high level, I'm just giving you the names, but again, so how they will be integrated with each of these things. So I'll anyway explain you. Okay. So how Spark integrates with HDFS. How does Spark integrates with Yarn? How does it integrates with Hive? How does it integrates with HBase? Okay, even Uzi. Uzi is plain simple. So all these things you can Spark integration with Kafka. Yeah, all these things you will see in our course itself. So in Uzi, there is nothing new that I have to show here, but I'll put it at the end. It's same as any other regular workflow, just you need to provide that Spark app there. So all these integrations you will see in our course. Okay. And yeah, basic definitions. So what is Spark and how does it got evolved, this stuff? Is the same typical definitions similar to your Hadoop. Apache Spark is an open source parallel data processing framework which uses in-memory cluster computing, which can access faster than disk access. So just feel free to stop me if you are not able to understand any of these things. So I'm not a big fan in explaining these kind of definitions. More interested towards talking in kind of real-time things. Okay. So open source anyway, everyone knows that everyone can download this and use it. So parallel data processing framework means distributed framework. Obviously, similar to your Hadoop, this is also distributed where the Spark services are installed on many different machines and they all are connected into one network, which is called as cluster. That is Spark cluster. And out of that Spark cluster, it uses the RAM memory of each of the slave machines, and it runs faster than your Hadoop because of RAM memory. So in MapReduce, we can use data node disk memory, whereas in Spark, it's limited to use RAM memory only. So how it's efficient over MapReduce? Good questions, and these are common expected questions. Anyway, I'll be answering these questions in a strategic manner. So based on the context. So I know I can expect these basic questions from each one of you. Okay. So I have real confusion in understanding difference between Hadoop and Spark. So can you please identify differences? Okay. I'll first help you, Mani. Okay. So later on, please share us interview questions for Spark and Scala. Yeah, sure. I'll highlight on which topics that you can expect your interview questions, both from theory perspective and as well as programming perspective. Okay. Okay. Yeah. So I can understand your situation, Mani. So except you, everyone has enough knowledge on basic Hadoop, but yeah, but I'll try to make it clear for you as well. Okay. So in general, so I hope you would be knowing the parallel processing of Hadoop at least, which means, okay, maybe, okay. So what I put in. Okay, let me join from a different machine as well. I'll try to just revise the basic simple HDFS and MapReduce architecture. So 536. Five, 3, 6, 2, 8, 4. Okay. So you can see this whiteboard. So in your basic HDFS and any distributed architecture, so if you take any distributed architecture, it could be your HDFS, it could be your MapReduce, it could be your HBase, or it could be your Spark as well. So in a distributed processing frameworks, so distributed means you have to distribute your work among many machines, right? So you have, instead of one large machine, one large huge server, so you have many small servers connected into a network, and your work got split between these different servers. And all these different servers started processing your input data parallelly, and they produced partial results, and those partial results will be aggregated and sent back to the client. This is the basic fundamental idea in any distributed processing framework. It could be HDFS, it could be MapReduce, it could be your HBase or Spark, whatever it is. In any master slave or any distributed processing framework. So in distributed processing framework, whatever it is, the technology that you are using, you need one or two masters. So there is a need of one master at least one master. So that if there is any client, let's say there is one guy sitting here, say Subbu sitting, he wants to process a particular file. So if there is no master, then he has to talk with any of these resources, and he doesn't know with whom he he can talk at that moment. For that reason, so in any distributed processing framework, there will be one master. This is something like your project manager, and these are your project team members. Okay, so in this master-slave architecture, both Hadoop and Spark also master-slave based architectures only. Here, let's say I have one big file, which is 10 GB, or for simplicity, I'll take, since I have five slave machines here, I'll take 5 GB file. I'm not going much in-depth low-level details here on high level. So let's take, you have 5 GB of huge file, so which you have uploaded to HDFS, and assume that it got equally split, and so you got 1 GB on this, and 1 GB on this, 1 GB on this. So each one of your slave machine got 1 GB, 1 GB now. So HDFS is now distributed your file, one file, into 5 small files. Okay. So of course, if I go much deeper into the HDFS details, it is not even 1 GB files. It will be either 128 MB blocks or 256 MB blocks. Okay. Now, so if you process this 5 GB file with your yarn or MapReduce, so there will be a yarn child will be spawned, means the yarn child task will be created. Yarn child task means, which is a JVM task. So all these HDFS, yarn, Spark, everything will run under JVM tasks only. So that means the underlying, you need JVM, which means Java. Okay, so if you have your 5 GB file and got split into 5 1 GB files, and if you have to process this, if you want to search for how many times the word Databricks or big data has appeared in this, or so how many records that have this word and you want to filter them or something like that. So let's take simple example that you want to see how many times the word Databricks has appeared in this 5 GB file. Now, in processing of this 1 GB file in yarn, this reads this 1 GB file by the yarn task or yarn child. Yarn child separate JVM task. Let's say if you take this as JVM task that is running, this reads the 1 GB file present on this HDFS directly from the HDFS, record by record, and then produces the results. So which means your input is being read from HDFS system. And similarly, this JVM task so reads your input from HDFS file record by record. So that happens in MapReduce. And so if you take in any processing input, intermediate, output, and final output. Okay. So these will be the stages in any processing, right? So whatever you take, there will be some input. Sometimes directly from input, final output you will get. Sometimes there is a chance that you may get intermediate output as well, right? So if you are using MapReduce, your input is HDFS, and intermediate output is local file system. If you have undergone that or training, so or for you money, the intermediate output will be stored in the local file system of this machine. The output from this task will be stored in this machine in the local file system, and from this machine, local file system of this machine, and from this JVM task in the local file system of this machine. And final output could be on your HDFS. But coming to the Spark, of course, your data is in HDFS only. Your 1 GB, 1 GB, 1 GB is right now present in HDFS only. But in Spark, how it does is, it loads that entire 1 GB block into the RAM memory. It loads. It will not read. It will not read from the HDFS line by line. It loads that block as is into RAM memory. And once it is loaded into RAM, it reads from that RAM. And I hope everyone is aware that so reading from, okay, let's go. So this is HDFS, this is LFS, this is again HDFS. This has gone. Okay. So reading anything from RAM memory will always be faster than reading from your local file system. And reading from local file system is always faster than reading from HDFS. Right? No, don't get misunderstand with that splitting part here, Satish. Splitting will be there as is in HDFS. Okay. I'm not going that level, that's it. I'm not talking in terms of blocks and their replications and all that stuff right now, because if I go that level, it will become like HDFS session now. Okay, that's the reason I'm okay. Okay, Akhil, no problem. You can leave. So here, so this block, this chunk of data is loaded at once, and from RAM memory, the data is being read. Not from HDFS. Now the data is being read from RAM memory. So that is the reason why your reading will be much faster in RAM, in Spark. And when it comes to these three stages, even these three stages, so your input is being read from RAM, and intermediate output will also be into RAM, and final output onto your HDFS or LFS, wherever it is needed. Okay. So since Spark reads things from RAM memory and stores the intermediate output also in RAM memory, processes them. So that is the reason why Spark runs much faster than your MapReduce or your Hadoop. So basic Hadoop framework means it's MapReduce. And as per the theoretical presentations or whatever it is, there are scenarios, there are times where Spark ran 100 times faster than your Hadoop. So RAM memory of data nodes, yes, RAM memory of data nodes only, not the RAM memory of master nodes. Okay, obviously you should have good amount of RAM memory. So if you are going to use the Spark, so that is where the trade-off comes. That is where the architects decide. So whether we need to go for the Spark for these kind of applications or not. Yes, we integrate Spark with Hadoop. So we make use of the HDFS framework and we make use of the Yarn framework. So Yarn is, I made it clear when I was explaining MapReduce and Yarn. MapReduce is a processing engine, whereas Yarn is a resource management framework. Okay, so maybe if you have forgotten these things, once again I'll explain during your Spark integration with Yarn. Don't worry. So I'll come to all these things, Raj. Okay, I'll explain you the cluster configurations, all those things. I'll explain you. Yeah. So how much RAM memory we allocate and via which resource management framework, all those things. Okay. It integrates with Hadoop, Satish. Of course, it's a separate framework. You can integrate this with Hadoop for your question. Okay. So, any questions on how Spark runs faster than Hadoop? I gave you basic idea only. I did not go much deeper. But going forward, once you go through each of these concepts, you'll understand one by one. Manichandra. So are you clear that? So why Spark runs faster? Okay. Okay, so in the beginning, so you might be seeing me, I might be going a little slow. I think you might be, some folks who already have this knowledge might get bored, but just bear with me, okay? So until everyone gets onto the same page. Okay. So that is one major difference that you will see in everywhere, that Spark runs reading data from RAM memory, and your Hadoop or MapReduce framework runs from reading from the disk. Okay. And Spark was originally developed from AmpLab, which is now a Databricks company. Okay. And they are the major contributors toward the Spark framework. Like HDFS and MapReduce, Yarn, these have been contributed from Yahoo, right? And of course, So now the major contribution is from Cloudera and Hortonworks, because these are the market leaders in the Hadoop vendors. Okay. This is a typical historical points about this. So this was started around 2009 and first open sourced in early 2010, and it became the top level project in around 2013. Sorry, it first got contributed to Apache in 2013, and later in Feb 2014 it became a top level project. That means almost 3 years back it became the top level project. And from code base size also, Spark is very smaller in size when compared to Hadoop. So around 20,000 plus lines of code. And in Hadoop, so it would be more than 1 lakh lines of code. Okay. So next, so why Spark? Obviously, the speed. The first one is performance. So Spark runs programs up to 100 times faster. So by loading things into RAM memory. So ease of use, which is something like your Hadoop. So if you have to write, other than SQL queries, if you have to write any programming, so you have to go for MapReduce, and which is which will be easy only through the Java, and any other languages it's very, very difficult. But so Spark has very easy integration with multi languages. Like you can program with Java, you can program with Scala, you can program with Python, or you can program with R. So currently these are the 4 languages that has major support. So out of which Scala is most popular because of its crispy code. Okay. Anyway, we'll talk about Scala tomorrow. We'll get started with the Scala concepts from tomorrow onwards. So first, we'll talk about Scala programming features, functional programming, and then OOPS concepts. And once the Scala is complete, then we'll jump into the Spark architecture, Spark coding, Spark programming stuff. Okay. R, it's R. Okay. And no, R means it's not Ruby and Rails. It's kind of similar to SAS. It's R. That is again for data science. Mostly only data scientists will use that. Okay. Okay. So one reason you should go for is obviously the speed. Second reason, you can program. So of course, if you are from different backgrounds and if your client is only strict towards Python, yes, you can then still use Python with Spark. But whereas with Python with Hadoop, it's very complex stuff. And or if your client wants only to use Java, or if you want to use Spark with data science, you can use R language. So it has flexibility to support many languages. So that is second reason. And third is all things in one place. It means both the data engineering and data science can run under the same Spark, and that will give you the under the same umbrella, both engineering and science resources can work. Okay. Yeah. So if anyone is interested in R Studio, I mean, I have explained in our blog in one of the articles that RStudio integration with Hadoop, and similarly you can explore any programming in that, or Spark, or direct practicing. You can do with your Spark installation. You don't need any other thing. You can directly, there is a Spark or shell available also. I'll at least show you basic things for different stuff like PySpark, shell, and Spark or shell, and these things. Okay. So you can combine all these libraries seamlessly in the same application, and you can make use of all this. Okay. So the base core part is Apache Spark core or native, Spark SQL, Spark streaming, and machine learning. So can Spark use without using RAM memory like MapReduce? So without using RAM memory means the question itself not 100% correct. Like your MapReduce also uses RAM memory. Any processing uses RAM memory, but the amount of RAM memory that they use is less. That's it. Okay. So your MapReduce cannot run without using RAM memory, but it uses less amount of RAM memory because it reads a record by record from directly HDFS and puts that into RAM memory, and those instruction registers will be used, right? So every instruction will be processed through the registers and the assemblers. So those are nothing but your RAM space inside your CDM. So so this uses a little bit extra RAM memory, but if you have limited RAM memory, there is chances that you will run into memory out of exceptions, out of memory OEMs, out of memory exceptions. Okay. So so these are the three reasons. The previous one, speed and ease of integrity with many other languages, and so all tools in one place. And second one is integrity with many other distributed tools like Hadoop or Yarn or Mesos or some NoSQL databases like Cassandra, HBase, or Amazon S3, these things. Okay. So Mesos is something that this is a resource management framework similar to Yarn. Okay. So no one uses this Mesos at this moment in real time, but that is a resource management framework exactly similar to Yarn. But anyway, I'll explain these things in when we talk about Spark. Okay. So Spark can be run in many different ways. Spark can be run in, one is local mode, pseudo distributed, and fully distributed. So these terminologies you might have already heard during your Hadoop. Similarly, for Spark also local mode, pseudo distributed mode, and fully distributed mode. Under this local mode, pseudo distributed mode, I'll differentiate these things. Under fully distributed mode, again you have three types. One is standalone. Second one is Yarn. Again, in Yarn you will have two types, Yarn-client and Yarn-cluster. And in this you'll have Mesos. Here I'm just giving the names here. Okay, don't get worried about this many things at this moment. I'll anyway explain you in much more detail what is local mode, what exactly happens in local mode, what exactly happens in distributed mode. So how many different fully distributed modes, standalone mode. So how to submit a job in standalone mode, how to submit job in client mode, cluster mode, and Mesos will not be covering because I don't have Mesos cluster. But which is very, very, very least bothered. Okay, you will not expect yarn cluster with Mesos in your real time. Okay, so 99%, 99.99%, you will have yarn integrated clusters only in real time. Yarn integrated Spark clusters only. So why people go for yarn only? I'll explain you that time. Okay. So what are these advantages? What are the disadvantages of standalone mode? And why people only go for Spark, yarn, and why not Mesos also? Okay. Yarn only comes if you are integrating Spark with Yarn only comes if you are integrating Spark with Hadoop. No, if you are not integrating with Hadoop also, if you are not integrating Spark with Hadoop also, even with the basic Hadoop, Yarn will be there inside your MR. Okay. Mani, I can understand your situation, but try to call me after this session. I'll try to propose you some other different plans. How you can get this basic fundamental things. Okay, so I'll suggest you a few things so that. And anyway, for this week you will be fine as long as, because from tomorrow onwards we'll be starting with Scala, so the programming language. So once the Scala is completed, then only we'll enter into the Spark concepts again. Okay, so today is whatever the Spark concepts I'm giving you, this is just for kind of making you familiar with the terminologies and the basic fundamental idea that you can, Spark is supported in different languages. Spark runs mostly by using RAM memory, and Spark has integration with all the tools that I have shown you here, I have listed here. Okay, don't go much deeper into the concepts, don't worry. Anyway, this will be covered later. Okay, so this is not much important topic at this moment. Even if I explain, you will not be able to understand. So it has a different serialization techniques as well. Just understand that point. Okay, so because of these many reasons, so one would suggest to go for Spark. Speed and integrity with many languages, and you have the different tools as one package that you can do both engineering and as well as science together under the same umbrella, and integrity with many other distribution tools and different serialization mechanisms as well. Okay, so some people will ask me question that, so nowadays Spark is becoming popular, so I don't need to learn Hadoop, or will Hadoop will get obsolete very soon? Obviously the answer is no. So your Hadoop means both HDFS, Yarn, and MR, Pig, Hive, HBase, and few tools like Scoop and other stuff. Okay, so now, so once you migrate to Spark, the only things that get affected are the MapReduce and Pig and you can little bit eliminate scoop also, but not up to the most part of it. You can eliminate this one also, but there are some limitations. But you still need HDFS, which is a file system, distributed file system, and you need Yarn, resource management framework. You need Hive, you need HBase, you still need Uzi, all those things. So your Spark is not going to obsolete your Hadoop. This is one common basic question that I expect from people, that many people used to ask me. Okay, so just give me a call, Mani, after this session. I'll help you understand more on that. Okay. So even in Spark, you will still be using in real time. 90% of the scenarios, the underlying file system would be HDFS only, or HBase, HDFS or HBase. So HBase means, which means again internally the HDFS only. Okay, of course Spark can run without HDFS also. There is a lot of difference. It can run without HDFS, and it runs on HDFS most of the time. So there is huge difference in its ability and in its usage. Okay, so it is 90% of the scenarios, the underlying file system would be in HDFS only. You'll still need Hadoop, and you'll still need Yarn framework. So out of the resource management frameworks, all these three are resource management frameworks. Spark, either go by Spark standalone resource management framework or Yarn resource management framework and Mesos. So out of these 99.99 scenarios, Yarn will be the resource management framework that will be picked up in real time. Okay. So Spark core with different languages. It could be Java, it could be Scala, Python, and R. And on top of the Spark core, Spark data frames concept has evolved, which made the programmer's life easy by supporting the SQL using the Spark SQL. And on top of Spark SQL, so one can write SQL queries and process the data. And Spark streaming is something that to process the real-time live streaming data. Okay, so this is where I'll be showing you Spark streaming, Kafka, and HBase, and all those integrations. Okay, so Spark machine learning, this is something that we are not covering, which is because even I am not much good expert in that, because I'm concentrated towards the engineering part of most of my experience, not towards the data science part. Okay, and all these Spark applications can be run under 3 different frameworks, resource management frameworks, out of which Yarn is the most popular one. Okay, so from today's session, I want you to be aware of these terminologies and how many languages, how many tools it can integrate with. Okay, and what is the scope that we'll be talking about. So this is just the same text about the previous slide. Yeah, Spark standalone, just for time being, you take this as terminal keyword. That's it. Okay. It can run, Spark can run without depending on Yarn framework or Mesos framework on its own. Spark can run on its own also. That is Spark standalone framework. Okay. And remaining stuff we will talk about, we'll talk during our so architecture. I did not talk anything about architecture right now, Subbu. I just have shown basic diagram. That's very, very, very basic. This one you are talking. Okay, so this one is not even the architecture. This is just a scope diagram, kind of what is there in any Spark application, kind of stuff. That's it. Okay. So I haven't entered into the architecture or the actual concepts of Spark yet. Okay. So, and I'll be doing that in the next week. So from tomorrow onwards, we'll talk about Scala. Okay. And since being the first day, many people might not be much prepared to grasp too many things in one day. I'll stop it for today here. And we'll firstly start with tomorrow on Scala. So on Scala, we'll need at least 6 to 7 sessions. So could you please share what I may have missed? Yeah, you can give me a call, Jyoti. I'll explain you what is the process. Then I can help you on that. Okay. So I thought you had enough time. That's why I recommended what to go through for you, Jyoti. So yeah, if you could have, yeah. Anyway, no problem. Okay, I can give you, if I could cover enough context to give the coding exercises. Okay, something like today, I cannot give you anything. Okay. So how much coding effort will be required in Spark compared to MR? Spark, you can do both the Spark native programming and as well as the Spark SQL programming. But in my opinion, Spark SQL and Spark native will be 50-50%. But even the native will be very simple when you compare to MapReduce programming. So when you compare to Java, OOPS concepts, all those concepts. So I mean, it's not just my field that I'm experienced into this. I can give. I mean, it's based on the few resources from previous batches who are coming from non-programming background. That's it. Okay. Spark means programming only. Like, so MR means programming only, right? Coding effort only. So in Hadoop, you can try to avoid MR by using Hive or Pig or these things. The way you felt Pig, so here more or less similar to that. Oh, okay, good. Okay, I'll see, Subbu, if I have any. There should be SMTP integration. The code, I don't see any issues with code you might be writing. So I'm guessing that there might be issue with your SMTP server and setup in your machine if you have to send any emails. Okay. Okay, so I'll stop it here for today, and I'll pass for any general questions for another 10-15 minutes. And then tomorrow we'll continue with freshly with the Scala part. Same time, every day the same time, 7 a.m. IST. So even though there is only one guy from India, I'll get used to talk in IST timings, but I hope you can convert that. And which is 7 a.m. IST means 9:30 p.m. EST. Okay, so all are from North American time zone only. Yeah, we can do little bit adjustments if you need in the time. Yes, I'll do that for every batch, Raj Kamal. Let me see. I'll create. So once, yeah. So 9:30 is good for me. So it's too late, Shiva. Okay. So what about 8:30 or 9 p.m.? Thing is, I need to wake up early. That's the problem. Vijay, you had the same Hadoop sessions, right?
Hadoop is from 8:30
Yeah,
hours
at
to
that
9.
time daylight saving was there. That's the reason. Let me see. Please stick to the same time as we have already scheduled everything around this. Okay. Yeah, let's see. Okay. I'll create the WhatsApp group. Let's see. I think if everyone else is fine with the same timing, we'll talk, Vijaya, how we can do this. Okay. Sending my MS programs sessions prior to this. Okay. Any other open questions? So I can give you a soft copy of certificate, but I don't know how much that will get recognition. Jyoti, that's yeah. But this is not an institute or like kind of stuff where yeah they. So this is some by real time guys just out of the free time we are giving it, right? But I don't know like how much that helps you. Okay. Yeah, those things you'll get at the end, Raj. Okay, I'll give those real time POCs. Don't worry. Cassandra, mostly I'll not be covering. I'll be giving with HBase, which is more or less similar. Yep. Okay. Ranjit, so can you ping me in WhatsApp once the session is complete? For the setup on system, what do we need to do? I'll help you on that, Raj. Okay. So I'll share the VM. You can set up, and I'll show you those setup things. Okay. Don't worry. And by the way, if you don't have anyone, I think everyone has my number. WhatsApp, just ping me from your WhatsApp numbers. 1704231873. Need that. Okay. So I'll be helping for that to everyone. Don't worry, Jyoti. Okay. As of now, I have set up. Yes, that should be fine. Yep. Okay. So just ping me from your WhatsApp numbers. I'll create a WhatsApp group. Okay. And then we will do any common communication from that. Okay. So any other questions? Okay. Thanks everyone. Then we'll continue tomorrow with a different topic, Scala. Okay. So we're going to keep all recordings. Yes, you'll get as usual this year. Okay. So you know all these things already. Okay. Yeah. Thanks everyone.